Okay, hi everyone. Let's look at the quiz questions from last week. Okay, here are the few questions. Let's see. Add a new line character to the good morning after good. So basically, just add a \n and why don't we just look at the answer here? So just add a \n there. And the next one, add a tab. So if we want to print this text out and then want to add a tab in front of the word morning, so you just put a \t as a tab. Okay. And third one, x equal to 100, y equals to 200. Use the if statement to print out this text x is smaller than y. So that's a check if x is smaller than y. If x is smaller than y, we print that out. So this is the code, the if logic. Okay. The next one, the same condition of a same still as above, but in what case we can print out is not smaller than y. So let's say if x is 300, y is 200, we use the same condition. Become if x is smaller than y, we print is smaller, else. So this is if else, and else is not smaller than y. And this since x is 300, that's not less than 200. So we should get that printed out. Okay. And next one, think about a scenario where we can utilize if, else, if, or you can have more else, if, and then else. So basically multiple conditions to check. You can think of anything you want. I came up with this thing. So let's say we have a state, the abbreviation, like Connecticut is a city. So then how do we check if this state is a city? So there's one thing, remember this is a string, and we have a string method called index of. That's to search for a text for this string. So basically we search the same thing. So if this string or state here contains city, then the index of actually start at position 0. So we should be able to get equal to 0. Then we can print out Connecticut. And similarly, if the string contains MA, then we print out Massachusetts. And else if the state is New York, we print out New York. And I think we got enough else if. Else, that's the catch-all. So if nothing above, not above, then we say, okay, it's not a northeastern state. So that's of course, that's not fair. We got New Hampshire, the Maine, they are northeastern states, maybe even New Jersey, who knows? Just to use that as an example. So this is the example of is, else, else. And the last question, replace answer question 4 with a ternary statement. That's for this if else. Remember, for if else, we can use a ternary, basically single line for those multiple if else lines. So if x, again, if x is integer x is 300, 100, then we want to save the text to a string. So the string equal to if x is less than y, then we assign the value, this text, to the as a result. Otherwise, or is else, then we print that out. So in this case, we should get that to the string and then we print out. Okay, how many of you did try to answer these questions? Let's say yes, or you can say yes in the chat. I just want to see how many of you really tried it. Let me check the chat window. Where's my chat window? Okay. It's okay if you did it, but if you did try it, just let me know if you tried it. And or if you find the questions too hard, you can say something as well. Okay, then that's fine. So that's the review of the lesson 8. Now let's move on to lesson 9. We are going to learn something new. It's called a switch statement. Remember when we look at the if else, we may have some, situations where we have to use a lot if else, too many else, too many conditions. But sometimes we can, instead of using those if else and check multiple conditions and make the code messy, then we can use switch instead. So the switch statement can be used to select one of the multiple code blocks. This is the code block 1, code block 2, or code block 3, etc. And so we evaluate the value of this condition or expression and match the value of that expression with the case values, value. If the value is X, we do that part. And if the value equal to this value here, we do this part, run this part. Or if the value, matches none of those, neither of those values, and then there's a default. So this is like a catch-all, just like the else in the if statement. We run, the default code block. So remember the keywords here: switch, that's one, case, break, and default. So we have 1, 2, 3, 4 keywords in switch statements. Of course, the default I think is optional. It's nice to have, but you don't have to have default. Even the break is optional. So we'll talk about that a little later. But there's a subtle difference if you drop the break. So we will talk that later. But let's first look at an example here where we can use the switch statements. Let's say we have a day variable. It's an integer. Day like in this case, we're talking about the weekday. Maybe we should just say weekday. So the weekday value is from 1 to 7. The 1 means Monday, 2 Tuesday, weekday 3 means Wednesday, and so on. Sometimes we can use a day start with 0, like day 0 is Sunday, and then day 1 is Monday. So it's okay. In this case, we use day 7 is Sunday. That's fine too. So the switch, we use a switch, evaluate the day, and match the day with the case value here. So let's say if the day is 4, then the switch will evaluate the day is 4, a check case 1, no, 2, no, 4, no, or 4, or 3, no, and then, okay, match 4. Then with match 4, I run this part, and there's a break here, okay? The break means, okay, I find the match value, run this line, and then the break means break out of this loop, this block, this from here to here, means break means jump out, break means jump to the up end of this switch block and skip all those things. Don't bother to check. If there's a long list here, if you don't break, it will continue to check is 5. If there's no break here, it's okay, it's 6. Of course not. So functionally, it doesn't do much, but it takes time to check them, and then that's that contribute more computing time. So it's a good idea to have break. Okay, why don't we try this switch example here? Just copy that here. Okay, and let's run. We should get a third state, of course. Yeah, that's a state. So if the day is, say, 5 or 6, then we should get a sunny day. So run it. Right? Okay, so we get sunny day. So this is how we use the switch. So when the code runs, it check actually case 1 not. If it's not, it won't run those, right? Because it doesn't match 1. Just check it and then jump to check this 2, no. Check 3, no. So keep jumping. I never really run those things. That's why I don't print those out. So when it's 6, it match this one and print out Saturday, and then break. Break means jump outside, jump outside here, jump here. Okay, I jump here and then nothing else to run, so then just finish. So that's how they switch. In this one, you can see that there's no default value. There's no default. What if I get, I don't know, a number, how about 8? If we run it, it just nothing happen. So it says nothing happen. It just check each of them, no matching, no case match 8. It just like, doesn't do anything, doesn't do anything. It's a value. Ideally, actually, you can say default colon, that's the syntax, and say system dot out dot print, something like since day A is not a valid weekday, how about this? Hey, that's not a valid weekday. Right, so this is a default. And since there's nothing, no other code, so in this case, this break is optional. You can have it. It doesn't cause any error. But since nothing else before this closing curly braces, so this break doesn't really help. Doesn't help anything. So this is optional. This one really is optional. It doesn't even impact performance. This is one's optional. Okay. Let's run this. Now, since the day is A, we should get something at least something, not like a quiet nothing. So at least we'll get a warning. This may or may not be useful because sometimes you just don't care. Okay, if the day is not between 1 and 7, I just don't care. I don't want to see anything. So in that case, this default, block is, you can just delete it. But sometimes you want to follow the flow, and you want to see, what happened. If not Monday through Sunday, I still want to see something. Then you add this default to catch the value in case the day value, is not 1 through 7, is something else. So that's the use of default. And let's see, is there another example here? Oh yeah, this is when you look at the switch, this is always like, like for the weekdays and months, a good candidate to show the concept. So in this second example, basically we want to check the month, right? The month, if the month value is 1, then that's January, and 2, that's February, all the way to 12, December, right? So let's add something. Let's call it that. Okay, this is called a switch. You can see that switch case switch. The code looks like a short, nice and neat. Imagine if you use the if month equals to 1, do that. Else, if the month equals to 2, do that. So it's a little bit messier, but the switch case, looks nice. Let's try this one. So we want to print month 4. So that's April. Yeah, we got April. If the month is 9, we should, so 9 is here, match 9 and print September out. Okay. So that's September. And again, if someone enter month 19 or whatever a value greater than 12 or even less than 1, then that's not a valid month. If we run it, the code just like show nothing, show nothing. So then again, we can use the default to catch default. And so C out. So C out. No, never got that work anyway. System out. That print again to say not a valid month as a warning. No break is needed, so we just print that. 19 is not a valid month, so we got a not a valid month, and that's fine. Well, sometimes this line is useful because when you write a program and then you check the month, and then if the month value is not from 1 to 12, if you don't print out this thing, then you just like you don't know what happened. And when you print all this out, so it's kind of debugging info. And this give you, hey, you got an invalid month value instead of quietly and didn't warn you this. The break, what if I say, hey, if I get rid of the break, what happened? And let's say the value is 9. So it will match that, print that out. Instead of jump out, a continue to the next checking. Okay, necking, not that one, and then not that one. See what happened. Let's see. You see that? We got both September and October. That's kind of interesting. That's a really unexpected behavior. So we know the month is 9. We match that, print the September out. We didn't break. So it just went ahead and print up October, even skip this check and hit the break and then they finish it. So that's really, really interesting. So if you match one, print that and run that, and ignore that line. This is a really, so that's just like unexpected behavior. So to be safe, always use break. So, you know, it's done with 9 and then that's it. Just break the block. Don't continue. So if we add a break there, we should only print out September. Yeah, that's better. Actually, I want to try that outside. Get rid of that. And I want to save it. Instead of running in this interface, I want to run in the command. So I want to run in this command line. Let's see what happens. My book. We are talking about switch. Remember, we can do this from the command line Java C switch compile. Let's compile. Now run the code switch class. I think don't even class, just that. And oh, that's same. So it's same behavior. So without that break statement, when then we got yeah, same result. So we do need a break to stop it. Okay, let's see. So to summarize, the break keyword breaks out of the switch block. It stops the execution of more code and the case testing inside that switch block. Break can save execution time because it ignores execution of all the rest of the code in that switch block. And the default specifies some code to run if there's no case match. You know, if the expression match no case value. So more example, oh here, that's, yeah, we look at that example here. Monday, Tuesday, let's try that. quick value. Put that there. So what this part is doing, we check the day. If the day is 1-5, that's Monday to Friday. Then otherwise, it says good weekend. That means, oh, okay, you know, the day value is not a weekday value, then it must be weekend. Well, if it's, you know, if it's A, then that's not weekend. But anyway, assume that no one enter a day value beyond 7 and 1. So if it's a 4, that's Thursday, right? It's Thursday. If it's 6, that's a Saturday. The Saturday, we don't check a Saturday. We assume Saturday belong to, you know, the default. So that's a good weekend. Have a good weekend. And same thing to 7, actually, in the run again. So that's still good weekend. Of course, if you enter in a not valid day, not, you know, not a weekday, not weekend, it's still treated as a weekend, still good weekend. But anyway, that's you know, the flaw of this code. But it's okay, you got the idea. We only separate the weekdays and the non-weekdays out. Okay, that's how we use the default. The second example, what's the second example? Oh, the second example is using the expression. Remember here, the expression here doesn't always have to be a number. It can be a character or can be a string even. So let's say if it's a character, let's say character is D. Let's see what happens there. Pasting. Yeah, we call it a character. Maybe we call it a grade. How about grade? And let's say take exam, you get some score. You know, if you get in order to get a grade of A, B, C, D, or F, of course, then let's check the grade. You know, if your grade is D, then your score probably is below 70 and above 60 points. If you get an A, then your score has to be more than 90 or equal, greater than or equal to 90 points. So let's see how that works on that. So since you got a grade D, let's say grade D, right? Oh, how about this thing? It sounds readable. Let's see, your grade. Remember the plus sign to concatenate two strings. Your grade is that, and then the score points is that. Let's see how that works. Yeah, your grade is D, so your points, your score is between 60 and 70, right? Then if let's say got an A, not VA, if you got an A, your grade is A, that means your score is more than 90 points. Well, in case not you, maybe me, I got an F, I failed. That means my score is less than 60, below 60 points, very bad. So that's how this, that's, you can, you know, the switch works. So A, B, C, D. You can even, you know, add something, put an F here. Oops. Okay. Oh. Say F. That means less than 60. Oh, yeah, less than 60. Right. And there's no default. That's fine. So F, oh, well, that's same thing. So F, in case of F, so that's 60. Right? So it doesn't have to be int here. That's a switch. That's a switch statements. Now let's move on to another one. Something new. It's not the if else or switch thing. It's one of the loops. You know, in any language, any computer programming language, there are loops. The loops means you run a piece of code repeatedly. You know, the looping, keep running on that code. Of course, you don't want, you know, really looping forever. That's called an infinite loop. Then your program never end. You know, never end. That's a big waste of a CPU or computer time. But when you the loop has to be like a necessary. You want loop a block of code only if it's necessary, and I'll show you that. So loop basically run a piece of code repeatedly, the loops actually can save time and save the number of lines, the code lines, and also make the code more readable. If you don't use a loop, you know, you don't use a loop when you have to run something, you know, multiple times, then you can just like write those lines, you know, keep writing those, repeat those lines. And that's, you know, a way to repeat, but obviously you got many lines to write. And that can introduce syntax errors and so on. So one of the loops actually is called a while loop. The syntax is while a condition is true, you know, you put a condition here. Remember the condition is a test on some value or some comparison, something like that. If the condition is true, while the condition is true, then it keep running that. It run that and come back, you know, run the code and come back, check again. If this condition is still true, it run again and keep checking until the condition becomes false or not true. Then it stops. Okay, that's a while loop. Keyword while, that's it. And then there's a, you know, check the condition. So here's an example here. Let's say we have an integer I equal to 0, and then this condition check is I smaller than 5? If yes, then print that value out. Then you increase this variable by 1. Remember this double plus sign? That's the you know, increment. That means increase the variable by 1. And so since the I keep going up, you know, let's say the first pass I is 0, Okay, yeah, that's a 5. You print I, that's 0. You print 0. And then increase 1 and come back. Okay, now it's 1. 1 still less than 5. Okay, print I, that's 1. So far you print 0, you print out 1, and increase the I by another 1. So that's 2 now. The 2, okay, print out 2, and loop back, and until the I is a 5. And then check that, okay, 5 is not at that 5, then stop. It won't do anything. So with this example, we will see that it will print out 0, 1, 2, 3, 4. Not a 5, because the 5 is not less than 5. It won't do it. The code will break, will stop and jump to the end or outside of the while block when I is 5. Let's try that code. I think I created loops here. Paste that in. Add something here, make it nice. Yep. So we expect 0, 1, 2, 3, 4. Let's see if that's the case. There we go. So it's the loop. First check, the loop 1, print 0, and loop 2, print 1, and so on, and until the I is 5, and then jump to the end. So we print this out. So this is a loop. If I comment that out, okay, then this thing will print like 0, 0, 0 forever, and you have to kill this job, otherwise this thing will keep running. Normally don't even want to try that because that will print the screen like all the zeros forever, never stop. The way to stop is sometimes you can kill the job from the control panel, or you can just even power off your computer. So never try that. Don't even try that. That's not bad, not good at all. So make sure, when you check something, make sure that value change, change to the opposite direction. Make sure it meet this value, try to close or, basically try to break that condition. Otherwise the loop keep going back, All right, let's see, another example. It's just similar to this one, a little bit different. This code is what this code is doing. Remember the last one from 0. Now this one from, let's say, 100. Is I greater than 85? Yes, okay, then print 100 out. And then next line, you have to change this value. If you don't change, then it will keep print that, 100 forever. So you decrease that the I by 1. So now it's 99. That's still greater than 85. So next one you print 99, and then all the way until the I decrease to 85. Then that's not greater than 85. So then that will stop. So you print 100, 99, and then all the way down to 86. Let's see if that's the case. Yeah. See, first one is 100. Decrease until it print 86, still greater than 85. Print out until when the I reach 85, then the condition is false. It's not true anymore. Then it jump to end of the while. It jump here or outside the while loop. So that's the second example here. Okay. And I think that's it. if you want to actually, you know, let's say I want to print all the odd numbers of not odd, odd numbers, you know, odd numbers. That means if you check that, it will print out, you know, all the numbers between 0, you know, between 0 and 100, right? Or from 1 to 100, see, that's it. But if you want to print out every other number, not all the numbers, then you can do this. I equal to, oh, remember that one, the assignment variable. Remember that. Instead of decrease by 1, now decrease by 2. Now see what happens. Oh, yeah. I scroll up too much. So in this case, print 100, decrease by 2, that's 98 and 96. See, you print all the see all the numbers that divided by 2, not even numbers. See, you print out all the even numbers. You say, what if I want to print the all the odd numbers? Then if you decrease by 2, then you have to start with maybe 99, because 100 is even number, so you don't want to start with 100, you want to start with 99, but still decrease by 2. Now you print out all the odd numbers. Say 1, 3, 5, 7, 9. And yep, 99, 97. See, all the odd numbers. This is how you use the while loop and then change this called a counter or pointer, a counter variable, and print the numbers you want to. All right. Okay, I think that's it for today. And quiz questions. This time I don't give you that many. I give you only 2. One is to look at the switch statements. I intentionally drop out something. I drop out something. If you copy paste this in, then you get syntax errors. I want you to fix this code, put back the necessary, symbols, keywords, make it as a normal or expected switch statement code. Okay. The next one, use a while loop to print all numbers from 100 to 120. So use something like that, and see if you can print out all the numbers between 100 and 20, including 100 and 120. Use a small while loop. Okay. All right then. Do you have any questions? If not.